We're going to start this section on decimals with this question here. Something to think about. Why are these three numbers equal? 0.1, 0.10, 0.100. So again, something to think about, and about why these numbers are equal, and even why students would not think they're equal, right? So think about that question. Where that now leads us to try to answer that question is understanding what decimals are, right? And decimals are used to represent fractions, right? But using our base 10 place value notation, as you can see here. Notice we have our place values, and then there's this decimal point that separates the ones, tens, hundreds, thousands position with what we call the tenths, hundreds, and thousands. And notice this is the same, it's keeping consistent with our base 10, 1 over 10, 1 over 100, 1 over 1,000, and hence the names. And so in this figure here, the decimal point is placed between, right, the ones and tenths column there. And what you see, this number here, 3,457 and 968 thousandths, you'll see the expanded form here. And so it stays consistent with our expanded form notation, and you will see this decimal then is represented as 3,457, 968 over 1,000, right? And so a decimal is just another way to write a fraction. You will see 100 squared to kind of represent this situation. If this whole thing is not 100 but 1, right? You can see the difference. This is 1 out of the 100. This is 10 out of the 100, 0.1, 1/10, here's 4/10, 7/100, right? And so you can look at it that way. The number line is also another way to represent decimals. You can take a look at how we have the number line and where it shows the locations of this one shows the locations of various points between 0 and 1. And so then you have these examples here to go over to look at how would we write each of these decimals, right? Fractions in decimal form. And so again, it goes by the wording here, 7/100. And so what we remember from our notation, right? You have your decimal here and your place values. And so in this case, this number here is 0.07, right? You have your decimal. Here's your ones position. There is 7/100, and so that's where that decimal comes from. At 123 and 10 thousandths, if we continue on with our place values, this is 1 over 1,000, and then the next one is 1 over 10,000. So our decimal has to be 1, 2, 3, 4 decimals long. So it's 0, 1, 2, 3. Now in this problem here, this one is interesting to look at, because as you look at this problem here, you'll see we have to convert that somehow into a decimal. So what I want to show you here is, now that you've seen how we completed the other ones, here is a blank place value system here. Here's the solution from the book, so you can look at that further and look at that notation there. But you will see here, in order to get this answer into a decimal, notice that we need to convert this here into the 7 over 8. I need to write it so that it has a power of 10 in its denominator. And the way we do that is we took the 7 over 8, which is, you will see here, that's the original 7 over 8. 7 over 2 times 2 times 2. And then I added 5 times 5 times 5, 5 times 5 times 5, right? That was the 8. And so then I end up with a base of 1,000, or denominator, which then allows me to then get 875 thousandths, right? And there's the expanded form for that. So I want to make sure you recognize how we turn that, how a fraction and a decimal are the same. We can, it's just another way to represent a fraction as a decimal. Here's 2 more examples here. Again, to make these into decimals, I need to make the denominators a power of 10. That's important to understand here on this problem. As you do that, this here, in order to make it a power of 10, I just need to add 5 to the power of 4. Because 2 to the power of 4 times 5 to the power of 4. Remember what happens here. We have a Something you have to recall from your rules of exponents is that, remember, so we end up with 2 to the power of 4, 5 to the power of 4. Notice that there's a 10 in there. That's the same as this. So there's my power of 10 right in here. So you can see if I want this to be a power of 10 without looking at the answer over there, right? What I need to do is I need this to be 5 to the power of 3 also. In order to get that, right, to make this a 5 to the power of the 3, I need to multiply the top by 5 to the power of 2 because there's already a 5. There's already a 5 down there. So it's 5 squared times 5 squared, and that's where you get your 5 times 2, your 10. So take a look at how that was converted there. Notice here 1250 is the same as 2 times 5 to the power of 4. And then I need to make it have the same powers, and then I can get my power of 10.